Okay, all of you got the formula? Scale, age, and other two. This is done, right? So in regression scale, calculate the average and standard deviation of these two variables, and then scale. So it's equal to average is equal to STDEV, standard deviation, no, here it is enter only. Control shift enter is for array formulas, index, match, those functions, we call them as array functions, matrix. There you press control plus shift plus enter. Is equal to open bracket age minus average fix it by pressing F4 divided by standard deviation Fn plus F is equal to open bracket loan minus this Fn plus F4 divided by standard deviation Fn plus F4. Find HPI, house price index, if age is 28 and loan is $78,000. You have to predict the HPI. Assume K is equal to 5. Calculate the Euclidean distance. Hmm. So the average is 174.6. You can see in the bottom. 174.6. The average of the first 5. You can see in the bottom 174.6. Averaging method for numerical data, majority voting method for classification data. ఏందబ్బా ఇది కొట్టినా కొట్టలేదు. స్టార్టింగ్ చేసిందా? Sort చేయాలి కదా. Euclidean distance has to be sorted, na? Smallest to largest. See, without sorting, how will you get the smallest distance? See, I will show you the visual representation of K and N.
A scale minus
See, this is the process. We are predicting for this, right? First step is it will calculate the distances, 2.1 to Euclidean distance only, 2.1, 2.4, 3.3, 4.5 for all the observations it will find, and find the neighbors. First neighbor, 2.1. If it is second neighbor, 2.4. Third neighbor, 3.1. Fourth is this. Now majority votes, you can see, right? 2 light greens and 1 green and brown. So this is the process. What we are doing is, without sorting, how will you know? Smallest to largest distance is the sorting, na? Once you sort only, you will know the smallest distance. The nearest point to it is these 2 greens, right? Light greens are the nearest. Majority voting also says class wins 2, 2, 1, 1, 1. You can look at this. So without sorting, how can you find minimums? Sort is compulsory, right? That too on distance. Chapandi, meeranti age?
Distance short చేసి automatically ఇటు కూడా అయిపోతుంది.
Anni expand sort vaadtam kada. It asks for expand sort, right? When you're sorting, it says expand sort. Yeah, all the others have to be sorted. See, when you say sort smallest to largest, it is asking for expand the selection. Expand selection means all other columns will also be sorted accordingly. That is a default option. Because if that column is sorted and others are not sorted, then our purpose is not met, right? What is our purpose? Other variables also have to change based on the distance. So expand sort is the default option. So it will automatically change the other variables also. You can see the sequencing of the variables also change. Then you take the top 3 or top 5 based on the distance, and you will see the average in the bottom, and then you will calculate you will get the final thing. In classification, majority voting; in regression, it is average.
So instead of calculating,
Yes. So if you are looking at Manhattan, the formula is what? For Manhattan, absolute xi minus yi. Sigma.
So suppose if you are not assuming any value of like in K and assume that value means what?
You have to assume the value of K at the beginning, randomly. You can take any number you want. Then after building the model, you will fine tune. If without giving the K, how can it will work?
No, is there any different method? Because
So what happens is, if you can't assume a single value, assume a range. It can be anything between 1 to 25. It can be anything between 1 to 50. Then we have to use grid search algorithms. Grid search. Grid search algorithms will do their work. It will try all the with k and k is equal to 1, k is equal to 2, k is equal to 3. It will build all the things and then it will automatically give you the final prediction. The process is same. Process remains the same. The k has to be assumed. In statistics, wherever you see k, it has to be assumed. What happened? You want the regression one, no?
Why it's called a Bayesian algorithm? Because
It will not do any calculation till the data is given for prediction. But whereas other algorithms, once you give the historical data, they will first do the predictions on historical data and store them. Based on that, they will create a model and store the model in the memory. Linear regression, decision tree, random forest, any other algorithm. Other than this, always create, for example, take for example multiple linear regression. It creates an equation and stores the equation in its memory. Similarly, decision tree. It creates a tree and stores it in a memory. So when you give a prediction to the tree, it will use the existing tree and then predicts. So that is what generally other models do. Here what happens is, it will only do the calculation only upon giving some predicted value. Which one? This one, right? So we are assuming k is equal to 5. So 1, 2, 3, 4, 5 after sorting, right? And you can see in the bottom the average 174.6. Or you can calculate here is equal to average 174.6. You can calculate the average. Yeah. Their majority voting. In classification, it is majority voting. In regression, it is average. Regression is numerical, right? We have to use majority voting. When there is a text data, you have to use majority voting. When it is numerical and continuous, you can use Got it? So guys, take a break and then we'll meet. Then we'll implement it in Python. Before that, we will do min-max scalar also. I'll show you how to implement min-max scalar also. Yeah, tell me.
Classification, if you are changing item like, the size will also change.
Yeah. See here. So 140, 50. Right? Now, only thing is you have to sort. Smallest to largest. Automatically it will change because we have done the index thing, right? That will automatically change. Which formula? This one, right? This is index and match function, which are array functions. Index array with mode. Mode is your frequent, most frequent. And then you are matching the 5 cells with the same 5 cells. We are looking for 0 is exact match. 0 is exact match. If you are looking at matching, match type is, see, lookup value is same table. Lookup array is also the same table. And match type is exact match. Exact match means 0. So index the table, comma, mode, most frequent of, match the same table with the same table. With exact match, you will get the most frequent. If it is number, we could have gone with mode, but it is this is a character thing, so we have to go with index match function. Okay. So guys, take a break. Online guys also. Okay. So if you want to use normalization method, so we have used scaling method, right? Yeah. So let us say, let us copy, move or copy, create a copy, move to end, click OK. Okay, classification 2. Okay. So this we will change it to min max. Create a copy and then let us remove this. Let us delete this. So min max scalar. Okay. So for min max scalar, you have to find the minimum, and you also need to find the maximum. Minimum and maximum. So is equal to min of the column is equal to max of the column. Close bracket, enter, and then bracket to the left. Control X. The min and the max. Now, height underscore normal or min max. Height underscore min max. Weight underscore min max. Okay. Now, what is the formula? X minus X min divided by X max minus X min. So let me put the formula also. So the min max scalar, this is the formula copy the image. Paste special if. So this is the min-max scalar formula. X minus X min, X minus X max minus X min. Similarly, let me give you the standard scalar also. Standard scalar formula here, which is Z score X minus mean divided by standard deviation. Put it here. Yes, special. Okay. So this is the standardization formula or standard score formula, which we have already used, X minus mean divided by standard deviation. So for min max, this is the formula, X minus X min divided by X max minus X min. So is equal to open bracket X minus X min. Now X min is common, right? Fn plus F4 divided by open bracket X max is also common, Fn plus F4 minus X min. Again select X min, Fn plus F4, close bracket. X minus X min divided by X max minus X min. Got 0. Double click. We will get the values. All the values are between 0 and 1. It will not go beyond it. 0 and 1. So this is the formula. X minus X min divided by X max minus X min. Normalization. Normalization we use in image processing because image processing is very large data, right? So min-max scalar is default scalar for image processing. Okay, same thing for weight. It's equal to open bracket X minus X min Fn plus F4 divided by open bracket X max Fn plus F4 minus X min Fn plus F4. Close bracket. Then double click. We'll get the values. Decrease decimal to for our sake. Here also is equal to open bracket X minus X min divided by open bracket X max minus X min. Close bracket, enter. Oh, how come we get minus 1.5? No, there's a mistake. Is equal to open bracket X minus, yeah, X min divided by X max minus X min. Right? How come I'm getting minus 1.5? No, it should not be below more than that. That means there is a problem here somewhere. Max and min and max. So, X minus X min divided by X max minus X min. We are getting negative values here. I think that because the data is out of the range. Data is out of the range, na? If I make it 160 and 70, because the data is out of the range. Why we are getting the negative values is data is out of the range. That is why we are getting the values. Even now, 70 is out of the range. So we will make it 65. See? It is out of the range. So that's why it is giving us the wrong thing. So it has to be within the range. Now we will calculate the normal Euclidean distance. Or we will calculate Manhattan. Manhattan distance. What is the formula for Manhattan? Absolute, huh? Absolute sigma is equal to absolute of this minus this. Sorry, this. Close bracket. This you have to put it as F1 plus F4. Plus absolute of 0.7 minus this F1 plus F4. Got a lot very good big values. So decrease the decimal to 3. Then sort and filter smallest to largest sort. And assuming k is equal to 5, 1, 2, 3, 4, 5. So 3L and 2M. 3, 2, 2. So Manhattan distance, let me just check if the formula is correct. Yeah, absolute, sigma absolute xi minus yi. Sigma means addition. Okay, ABS. Min-max scalar is used mostly in image processing. When you have extremely large data and you don't want negative values to create problem, then we use min-max.
I get the same thing, but I'm getting an error. It's unable to. What is that connection? Is it like Mac and?
Or I think the masking thing worked actually.
That M1, M2.
That thing might have worked. M1, M2, NP dot where thing, that will work, that would have worked. Try that, no?
Exactly.
Or do one thing, calculate the mean and fill in it with mean directly, 1.3 or something we got. See. Fill in it, so instead of doing the function.
Yeah, he'll be recording.
Previously got the session.
Yeah, he'll be recording.
See myself doing
Okay, so this is the method for running the KNN algorithm. Now, the thing we have to do is, if you open our Jupyter notebooks, the previous notebooks, PJ23, this naive Bayes all classification models is there, na? That you open and run all the cells. Naive Bayes classification model, run all the cells. Open that naive Bayes theory, all classification models, run all cells. Yeah, it ran for me. All of your notebooks ran?
Just asking like
So like he has done some. So the one which has done is great. So we have to give them the last.
now it works basic understanding. First we will be in Excel, then we will be doing it in Python. So here is now executing that same thing Python.
He said like he has done.
Previously we have completed some other so They're just running that already. Python, whenever you are starting the worksheet, you have to run everything from the beginning.
So what are the two this one is.
In Anaconda, you will be having this. Anaconda and everything. So if you are taking that mean, that circularly we so from that we can from the no, links are not given, it's directly available in Google. Links, yeah, you can see it. Yeah, yeah. So sir will be saving every recording and right. So if he gives you access, you can all that.
Okay, done for all of you? Yeah. So. So from sklearn dot neighbors, from sklearn dot neighbors, import k neighbors classifier, because this is a classification problem, right? Here our dependent variable is yes or no. If you remember, the dependent variable is yes or no. This is a classification problem. From sklearn dot model underscore selection, import grid search CV, grid search cross validation. Now we will give a short name to the model. KNN is equal to K neighbors classifier parenthesis. We'll give a short name. Now K underscore range is equal to list range 1 comma 20. So we are giving the range of K values from 1 to 20. Okay, because we are not going with single value, we are giving, it will try all the values between 1 to 20. Then we are also giving some other parameters also. Param underscore grade is equal to take n underscore neighbors is equal to k underscore range. N underscore neighbors is equal to k underscore range. Now grid is equal to grid search CV. KNN, comma, param grid, comma, CV is equal to 5. Grid underscore search is equal to grid dot fit x comma y. Oh. Unlike other reduction functions, Q kurtosis, the default behavior of mode typically preserves the exit it allows in. In SciPy 1 this will change. The default value of key brains will become false. The axis over which the stat mode k underscore neighbors axis is equal to 1. The warning is repeating here. So it has ran the model. Now we will find the best parameters. Grid underscore search dot best params. So n underscore neighbors 10 or k is equal to 10 is the best fit model. Grid underscore search dot best score 0.86 accuracy. So the k value here would be 10. It will try, it has tried all the values from 1 to 25 and k is equal to 10 or n underscore neighbors. Here we call it as n underscore neighbors is 10. The accuracy is 86.59. It has the highest accuracy. Now we will rebuild our model with thing, or we can use the same grid search for predicting the function. So it has tried all the things. That's why if you go here, it will give you 25 warnings. 25 times it tried the model, so it's giving you 25 warnings. You see, same warning it is repeating 25 times, right? And then it came up with the best parameter as 10, and 8659 is the accuracy of the best fit model. Okay, got it, all of you? Still running? Yeah. Hmm? You didn't get warnings. Okay, then it's okay, no problem. But find the best params. Grid underscore child run. See the best parameters. Got it? So same thing, you can run on the New York taxi data where we have built regression models. New York taxi data is there, na? New York City green taxi data. Where we have built all the regression models up to random forest, I think we have built, right? Oh shit, 3000, oh, it will take time. Faster. So New York City green taxi trips data. I reduce the random forest trees to 500 only because 3000 will take a lot of time. Because this is large data, so New York City. Actually, this data is a live data provided by New York City. Taxis are there, na? Yellow taxis are very popular in New York City. So the New York City state government only has given the data, monthly data they will give.
The one which you have done.
We have done it for June 2022. We have used the data of. So green taxis are CNG and electric vehicles. How many trips in the month they have taken? That yellow taxi is also there, but yellow taxi is larger data file. So we will be working with yellow taxi also sometime later. So we have downloaded this data from the New York City website, and then we have pre-processed the data, and then we have used we predicted the total amount. We built a model to predict the total amount, fair amount, based on parameters.
So the one which I explained just before the next stage, you are implementing those things.
Yes. So theory will be explained, and then calculation wherever is possible will be done in Excel to show the mathematical calculation, and then we'll implement it in Python or R. Not all, if random forest, you cannot implement it in Excel because it's an iterative algorithm. It cannot be done manually. So apart from random forest and gradient boosting, rest of all algorithms we will implement in Excel. We will show the background mathematical calculation, how the mathematical calculation works and how it gives. Well, so from same thing, from sklearn dot neighbors import k neighbors regressor. This is regression model, right? So numerical data, total amount you are predicting. Total amount is numerical. From sklearn dot model underscore selection import grid search CV. KNN is equal to k nearest neighbors regressor. Give a short name to the model. We will use the same. A underscore range is equal list range 1:20. 1:20. List range 1:20. Same param underscore grade is equal to n underscore neighbors is equal to a underscore range. Got it?
I use PowerShell
Ah,
and then I used all this mask and
ah,
it works. Sir. Like here I got this value just
ah,
one,
ah,
but it said it has one missing value in it.
ah.
Still
Let it drop in.
drop in it.
One row, no? Drop in. One drop, one value, no? Drop in. Just one row. It doesn't affect. Just drop it. Rather than wasting time, drop in. Grid set CV, KNN, param grade, comma, CV is equal to 5. Oh. I forgot dicta. Grid underscore search is equal to grid dot fit x comma y. Yeah, it gave me call.